The explosion of internet and web services is rapidly changing the way consumers behave and how business transactions are carried out. More than 2 billion consumers worldwide now use online services for an increasing variety of transactions. Likewise, mobile access is skyrocketing for shopping, content searching, social networking, and video streaming. Connectivity through the Internet of Things is constantly linking more users to more activities. One of the primary challenges with the growth of IoT and online services is the deployment of a suitable server infrastructure. Web service providers often find it impractical to run conventional high-power, high-performance servers that are costly to maintain. It is clear that cloud service providers don't need supercomputers for performing simple data transactions. The question many experts are asking is, why use expensive, power-hungry conventional processors when what is needed is a low-power system that gets the job done effectively and efficiently? In most commercial cloud service provider environments using conventional servers, a scheduler in the operating system must distribute tasks from the OS to the CPU. This forces the number of virtual CPUs to pick up slack when there are not enough physical CPUs to perform the tasks during peak times. This type of infrastructure requires OS virtualization to manage CPU performance because the virtual software within a CPU must process multiple tasks. The problem with CPU virtualization is excess power consumption and operating costs, even during off-peak times. For web service providers processing internet transactions, implementing this type of infrastructure is unnecessarily expensive and overkill. To minimize the power usage of physical CPU cores, the alternative is to assemble a large number of CPUs optimized for the applications being run. This achieves the same processing power while at the same time reducing the number of transistors operating unnecessarily to achieve peak efficiency. The result is lower power consumption and operating cost. In our solution that optimizes the hardware of systems and data centers providing e-commerce and search services, Socionext has considered the following criteria. First is the issue of scalability. The system architecture must scale easily so it can handle growing amounts of tasks while easily accommodating the need for increases in hardware. Second, power conservation must be considered so the CPUs can be set to idle when not in use. And third, the memory architecture should be optimized to prevent I/O bottlenecks. Considering CPU performance, I/O features, and network optimization, Socionext has chosen the ARM Cortex-A53, a low-power CPU core. The Socionext server is comprised of a total of 64 CPUs and 1,536 ARM Cortex-A53 cores. It starts with 24 cores on each CPU chip, with 8 CPU boards connected in a cascade on a system switchboard, and 8 system switchboards connected in a cascade to form a server rack. We have created a multi-core distributed processing server platform, a solution aimed at revolutionizing the hardware infrastructure for cloud services. To achieve the same performance as a conventional CPU, about 10 ARM Cortex-A53 CPU cores are required. Increasing the number of cores often leads to the notion of increased power consumption, but because the Cortex-A53 has a much higher power efficiency rating, a conventional chip operating at 2,060,000 DMIPS consumes 420 watts of power, whereas the Socionext multi-core CPU system uses only 141 watts, or only 1/3 the power. At the data center level, the Socionext server solution has a power efficiency about 2.5 times higher than conventional-based systems. Additionally, the Socionext small core solution does not require advanced water cooling, so the power usage effectiveness is superior. When performing a side-by-side comparison of power efficiency, the conventional system produces the value of 1.4 PUE, whereas the low-power multi-core system using power-efficient ARM cores has a PUE of just 1.2. In a data center with 300,000 servers, switching from conventional systems to Socionext-based systems would reduce the number of 10 megawatt wind turbines required to power the data center from 10 to 3.
The Socionext server system concept is based on our decades of experience in supporting many computer vendors. Its greatest advantages include scalability and low power consumption.
I am Seiji Goto, Engineering Manager of Server System Design. we can show the very high efficient server system. I believe this server system make your life changes.
Cloud server is just the first step of many core type systems. There are many different applications which require a host function, and most of them are simple operations. Each CPU node and multi-core CPU system can be seen as a channel interface for IoT devices. We see the market trend of many mobile devices shift their functions dedicated to sensors.
In the Socionext multi-core distributed processing system, our technologies are focused on low power consumption and high-speed networking implemented in the SoC. As a SoC solution vendor, we have developed a system from a combination of various cutting-edge technologies to create this ideal solution.
With the ever-growing demand for cloud data services, online service providers are looking for alternatives to having expensive, high-end, high-power cloud servers for performing internet transactions. Relying on conventional servers is similar to using a sledgehammer to crack a nut, when all these companies really need is a solution that can effectively and efficiently process simple data. The Socionext distributed multi-core processor system is an ideal, energy-efficient, cost-effective, and high-performance solution that meets all of their needs in a small, scalable architecture. By applying the practice of adhocracy innovation, Socionext aims to create a better future and a better quality of experience for people throughout the world.